In remote sensing, we can use lots of different instruments. The idea is really quite simple. We take an instrument, we put it on a satellite, we point it down towards Earth, and as the satellite is orbiting Earth, it's collecting information or data about the area that the satellite overflies, and we can use that data to study what's going on Earth under it. We can put these instruments on other kinds of platforms as well, on aircraft, boats, drones, cars. We can even hold them in our hands. But we're going to focus on satellite-based instruments in this course. So if we imagine that we have the Earth here, and we have a satellite in orbit around the Earth. I'm going to try to draw an orbit here. The kind of instrument that we typically use is a passive optical instrument that records the sunlight that's been reflected off the Earth's surface and come back up to the sensor. Passive optical instruments, you can think of them sort of as like the camera that you may have in your phone, but they don't work exactly the same way, because your camera has an aperture that opens, lets light into the sensor, and then closes again to make a photo. And you probably know that if you move your camera while you're taking the photo, the image gets blurry. And so that technology works well for your phone maybe, but it doesn't work so well for a satellite that typically moves at around 7 or 8 kilometers per second. So we use different kinds of instruments instead of cameras on satellites. There's two primary types of passive optical instruments that we use. One is called a line scanner, and it actually does work something a little bit like your phone, except instead of it creating an image that's 2 dimensions when the aperture opens, it creates something that's more like a single, like a one-dimensional image. And what that does is as the satellite orbits the Earth and looks down, it might look at a strip of the Earth's surface like this here. We call this the suborbital path in the middle. And as the sensor opens up and sees the Earth behind it, initially it just collects data on a very tiny little strip like this here. But it doesn't have an aperture that opens and closes. The aperture is open all of the time. So we collect this very, very tiny little image very, very quickly. And then a couple of microseconds later, because the satellite has moved in its orbit, we collect another little strip. And then another couple of microseconds later, we collect another little strip. And we keep on doing that until the satellite has passed half an orbit and collected data from the entire sunlit half of the Earth. In post-processing, we then take all of these individual little lines, we put them together. Initially, they get all put together into a big strip that covers the hemisphere of the Earth. And then later they can be cut into individual images for you to download from the internet. That looks something like this. This is called a line scanner or a push broom scanner. But there is an alternative technology as well, which is called a whisk broom scanner. The whisk broom scanner doesn't collect a line of data in each take. It actually just collects a very, very small, something closer to a rectangle in each take. And then it uses a little mirror to direct the light that's coming up from the Earth into the sensor. And that mirror can rotate so that as the satellite passes in its orbit, it can start to look over here and over here and over here and over here. And then it rotates back, and then it does this again. And so it keeps on collecting data from different parts of the image swath, which is what we call this band here. And afterwards, the same principle applies. We take all these individual little pieces of data, and we add them up into an image that you then get to download. So those are the two primary technologies that we use for passive optical imaging. There's other passive instruments in space that don't record reflected sunlight. Instead, we have thermal instruments that record the thermal radiation that's naturally emitted from Earth day and night. So that we can use to measure the temperature of the Earth's surface. And we have passive microwave instruments that do the same thing. They just measure longer wavelengths of radiation, and that can tell us also something about the temperature and about the moisture conditions on Earth. We also have a set of active instruments that we're going to look at in another video.